Continuing with our exam review, number 29, we have the average value of the function, and the function that we had was 4x minus x squared on the interval from 0 to 3. So average value of the function is 1 over b minus a, so our b is 3 and our a is 0, so 1 over 3 minus 0, and then the integration from 0 to 3 of the function. Now, I can do this on my calculator, so grab your calculator if you would. Alright, so again, a couple of ways that you can get to that. Integration. So we can do alpha window and choose number 4. Or we can go to math and choose number 9. So either one's going to put that integral on our calculator. So we could go through and put in our 0 and our 3 and our function. So 4x minus x squared, and then of course that's in terms of x. So the value of my integral is going to be 9. So that's where this 9 comes from right here. So 1/3 of 9 would give me 3. Alright, then for 30, we're asked to find the derivative, and we have a product. So we're going to use product rule, which is first times derivative of second plus second times derivative of first. So first was e to the x, second is ln x, so the derivative of that is 1 over x, plus second was ln x times the derivative of e to the x, and the derivative of e to the x is just e to the x, it's its own derivative. So e to the x times 1 over x is here, and then plus e to the x ln x. All right, then for 31, same idea. We have a product, and so we want to use our product rule. So we're going to do first times derivative of second. So second was s squared minus 1, so the derivative of that would be 2s plus 0, or 2s, plus second times derivative of first, and derivative of well, the first was s squared minus s plus 7, so that'd be 2s minus 1 plus 0. So again, first times derivative of second plus second times derivative of first. Now let's clean that up, so let's distribute the 2s to this first guy here. So 2s times s squared is 2s cubed, 2s times negative s is negative 2s squared, and 2s times 7 is 14s. Then here I'm going to FOIL. So I've got s squared times 2s is 2s cubed. S squared times negative 1 is negative s squared. Negative 1 times 2s is negative 2s. And negative 1 times negative 1 is positive 1. So combining like terms, we've got 2s cubed and 2s cubed. That's 4s cubed. And then negative 2s squared and a negative 1s squared is negative 3s squared. 14s and negative 2s is 12s, and then our plus 1. For 32, they wanted to know about the continuity of this piecewise function. So I need to check each of the individual functions. So first off, I need to look for continuity on 1 over x and continuity on x squared. The other place that I can run into trouble with a piecewise is where the pieces come together, so I also need to check at 1. Alright, so to begin with, for 1 over x, the continuity problem there is that it's not going to be defined at 0. It's going to be discontinuous at 0. But if you'll notice, I'm supposed to use 1 over x when x is greater than 1. 0 is not in that interval, so there's no problem there. If 0 had been in this interval, then yes, I would have had a discontinuity there. Alright, then for this other piece, this is a polynomial. Polynomials are continuous everywhere. So rational functions are continuous within their domain, and the only thing not in the domain was 0. And polynomials are continuous everywhere, so no issue there. So the last thing I want to check is where the pieces come together. That's at 1. So I'm going to check my 3-part definition of continuity at 1. So the first part is the function defined? So yes, when x is equal to 1, I'm supposed to use x squared, so that'd be 1 squared or 1. So yes, the function is defined and it's 1. Second, does the limit exist? So I need to check the limit from the right and the limit from the left and see if they're the same. So the limit from the right are the values greater than 1. So I'm going to use this top piece, 1 over x. So 1 over 1 would give me 1. And the limit from the left would be the values less than 1, that'd be x squared. So if I do direct substitution, I get 1. So since the limit from the right equals the limit from the left, then yes, the limit exists. And what we got for f of 1 is the same thing as what we got for the limit. So f of a is equal to the limit. So yes, it's continuous at 1. So that means that this function's continuous everywhere. For 33, we had the integration of a product. And remember, we do not have a product rule for integration. So there must be some way we could simplify that or use u substitution. So I'm going to use u substitution. I'm going to let u be my quantity, x cubed minus 4. So then the derivative of the x cubed minus 4 is 3x squared. Multiply both sides of that by dx, and the differential du will be 3x squared dx. So over here, you'll notice this is going to be u to the 5th, and what's left is x squared dx. So I need to replace x squared dx, not 3x squared dx. I need to get rid of that 3. So I'll divide both sides by 3, so 1/3 du is x squared dx. So again, this is u, so that would be u to the 5th. And then x squared dx would get replaced with 1/3 du. So let's move that 1/3 out in front to get it out of our way. And the antiderivative of u to the 5th, we're going to add 1 to 5, so that'd be u to the 6th over 6th. And so that would give us u to the 6th over 18, or 1/18 u to the 6th. Then don't forget to back substitute, x cubed minus 4 was u, and then of course plus c. For 34, they asked us to find the derivative of 3x minus 4 to the 8th. So the derivative of anything to the 8th would be 8 that thing to the 7th. But I also need to use chain rule here because this was a quantity. The derivative of the outside was 8, the function to the 7th. Now I need to multiply by the derivative of the inside, the derivative of the quantity. So the derivative of 3x minus 4 is just going to give us 3. So 8 times 3 is 24, and then 3x minus 4 to the 7th. All right, then for the last one, they ask us to find the second derivative. So I'm going to start with my original function. So 2 times 3 is going to give me 6x to the second, minus 5 times 2 is 10x to the first, plus 2, and then minus 0. So 6x squared minus 10x plus 2. The second derivative then, I would do 2 times 6 is 12x to the first, minus 10 plus 0, so 12x minus 10 would be my second derivative. And then the third derivative, if I take the derivative of 12x, that would be 12, and the derivative of 10 would be 0. So the third derivative would just be 12.